Bismillahirrahmanirrahim. Sallallahu alaihi wa alihi wasallam. Allahumma rabbi zidni ilma. Sallallahu alaihi wa alihi wasallam. Ameen. Alhamdulillahi rabbil alameen. The topic of this lecture is important concepts of Poisson distribution of S2. For this lecture, I am using the work of one of my best student, Miss Mahin Quraishi of class 2021, the Lyceum. To be good at math, we should follow this equation. Comprehensive concepts plus regular practice is equal to A star. Discrete probability distributions. There are three discrete probability distribution in our syllabus. You already have done these two distributions in your S1. Now we are doing Poisson distribution. Discrete means countable quantities. The knowledge of the normal and binomial distributions are required. Poisson distribution conditions. There are four conditions for Poisson model. Events occur singly, randomly, independently, and at a constant rate. Examples. Computer breakdowns occur randomly, on average once every 48 hours of use. Computer breakdowns means single events. And the unit is very important. Once every 48 hours. That means uh, the mean is 1, like lambda is 1. Lambda is basically mean for 48 hours. The number of emergency telephone calls is a single event. To an emergency center are 5 calls per hour. You may notice this thing. The unit, you will always get the unit 48 hours of use, 5 calls per hour, once every 48. This means mean is 1 for 48 hours. This means 5 is the mean for 1 hour. People arrive randomly and independently at the elevator in a block of flats at an average rate of 4 people every 5 minutes. So your mean is 4 for 5 minutes, for every 5 minutes. Men arrive at a clinic independently and at random at a constant mean rate of 0.2 per minute. Here mean is 0.2 per minute. You should be careful regarding the unit. If all the above conditions, these conditions, are satisfied, then x means discrete variable, the discrete random variable, will follow the Poisson distribution. And this is the way to write the distribution. And you can read this as x follows the Poisson distribution with parameter lambda. There is just one parameter of the distribution, which is lambda. In binomial, we have two parameters, n and p. And lambda is known as the mean or average or rate. Lambda is the only parameter of the distribution. Parameter means a quantity which defines the distribution. Lambda defines Poisson model. This is the formula of the distribution. E power minus lambda, lambda to the power x, x factorial. If you have x here, then it's lambda to the power x, x factorial, and e power minus lambda. And x can take any value from 0 to infinite, all integer values. Hence, Poisson distribution is an infinite distribution because of this thing. And x is discrete. Mean, this is the formula of mean of Poisson model, Poisson distribution. Mean is lambda and variance is also lambda. Therefore, mean is equal to variance is equal to lambda. So if any distribution has same mean and variance, then that distribution would be Poisson distribution. The mode. When lambda is an integer like 3, then there are two modes, 3 and one value which is below lambda. 2 and 3, that is lambda and lambda minus 1. So if lambda is 8, then there will be two modes, 8 and 7, lambda and lambda minus 1. When lambda is non-integer, then the mode is the integer below lambda, Like if lambda is 3.8, is lambda is 4.9, then the mode will be 4. If lambda is 3.8, then the mode will be 3. The mode is the integer below lambda, like 3 in this case. Rules for making calculations easy. Well, when we have to work for 0, when x is 0, then this formula will become e power minus lambda. When we have x1 here, then this formula will become lambda e minus lambda. These two rules are very important to make the calculations simple. So x0 means none, and the answer will be e power minus lambda. And 1, that means lambda e minus lambda. If we need probability x less than equal to 3, then the possible integers are 0, 1, 2, 3. And you just need to take e power minus lambda common. Let me do this step. Basically, we had this thing. Zero means e power minus lambda. 1 means e minus lambda, lambda power 1 over 1 factorial. 2 means e power minus lambda, lambda power 2 over 2 factorial. And 3 means e minus lambda, lambda cube over 3 factorial. So when you will take e power minus lambda common, you will get this thing. So make sure whenever you have to find probability of like this inequality, then first write all possible integers, then write e minus lambda here. For 0, always write 1. For 1, write lambda 1 over 1 factorial. For 2, write lambda power 2 over 2 factorial. And for 3, write lambda cube over 3 factorial. 3 means lambda cube over 3 factorial. Since we have 3 here, so this should be 3 factorial. 2, so 2 factorial. What if we need this probability? We cannot find this probability directly because there is no end of the values of x in Poisson. So we have to use the indirect method, which is 1 minus numbers which are not in this list. So we don't have 0, 1 and 2 in this list. So 1 minus 0, 1 or 2. So you should write this as e minus lambda. For 0, you should write 1. For 1, lambda power 1 over 1 factorial. And for 2, you should write lambda power 2 over 2 factorial. Here 3 was inclusive, so we started with 3. Here 3 is exclusive, so the direct method will start from 4. So we have to write 1 minus 0, 1, 2, 3. Always write direct method. I mean list all the, like you should write first possible integer, like 2, 3 possible integers, and then use 1 minus probability those numbers which are not in this direct method, in this list. So the best way of doing questions like this, first write direct method. Write the first possible integer, write 2 or 3 more integers, and then write 1 minus probability those numbers which are not in this list. So these numbers are not in this list. This is the safe way to solve questions like this. X less than 3 is simple. The possible numbers are 0, 1 and or 2. So for 0, write e minus lambda and 1 here. You first write e minus lambda, and for 0, write 1. For 1, write lambda power 1 over 1 factorial, and for 2, write lambda power 2 over 2 factorial. These rules will make your calculation very simple and fast. The next topic, the sum or total of independent Poisson variables. For two independent Poisson variables x and y, if x follows Poisson with mean lambda 1 and y follows Poisson with mean lambda 2, then their total or sum will be x plus y. This will follow Poisson with mean lambda 1 plus lambda 2. You just need to add these two lambdas. Note, Care must be taken regarding the value of lambda according to the given intervals, and use ratio method for the value of lambda. For example, this is a question from June 3, question 6, and question 3 in my booklet. Well, mean 1 in 48 hours, like one call in 48 hours. So, what about number of calls for 60 hours? What about the rate for 60 hours? So, you just use ratio method for that. So, 1.25 calls for 60 hours. So always use ratio method to get the value of lambda according to given unit. And x less than 4. X less than 4 means these are the possible numbers. You can check the question in past paper, and then you can check the solution. So we need less than 4 in 60 hours. Find the probability of fewer than 4 calls in 60 hours. So these are the possible integers according to this inequality. First write e power minus 1.25 because lambda, the value of lambda is 1.25. And for 0 write 1, for 1 write 1.25 power 1 over 1 factorial, 1.25 is basically lambda. This is lambda power 2 over 2 factorial, this is lambda power 3 over 3 factorial, and lambda is 1.25. And give your answer up to 3 significant figures. The last part of this question. Well, computer breakdowns occur once in 48 hours, and there are two emergency calls, two calls for computer breakdown in 24 hours. So first get lambda 1. Lambda 1 is this, and lambda 2 for 60 hours is this. Now get the total of these two lambdas. The total is 6.25. The question is find the probability that there are total 4 computer breakdowns and calls in 60 minutes. In 60 hours, sorry. This is 60 hours. Find the probability that there are total exactly 4 calls and computer breakdowns in 60 hours. So by using this formula, you can easily get this. E power minus lambda, lambda power 4, and 4 factorial. The value of lambda is 6.25. You can go through the question in past paper. This is the reference. Approximations. Well, in this chapter, you will do 2 approximations. Number 1, Poisson approximation to binomial distribution. This means Poisson approximation to the binomial distribution. Both are discrete. This one is discrete and this one is also discrete. So no continuity correction is required. Conditions. There are 2 conditions for Poisson approximation to binomial distribution. Number 1, n greater than 50, and number 2, p less than 0.1. If we have these 2 conditions in binomial distribution question, let's suppose we have this binomial, n is 60 and this is 0.02, then we can solve this question through Poisson approximation. And we have to solve. So x follows binomial with parameters np, x follows Poisson with parameter lambda, and the value of lambda will be np because mean is np and mean of Poisson is lambda. Therefore, we have np here. No continuity correction is needed. Normal approximation. Poisson. This means normal approximation to Poisson distribution. And since this one is discrete and this one is continuous, so we have to use continuity correction. We have to do continuity correction, in fact. This is just one condition for the normal approximation to Poisson distribution. Whenever lambda of Poisson is greater than 15, we always solve the question of Poisson through normal. And we write normal distribution like this, mu sigma square. Since the mean of Poisson is lambda and variance is also lambda, therefore mu is lambda and sigma square is also lambda. So a normal distribution will become lambda lambda. Poisson is discrete, normal is continuous, hence continuity correction is required. And the best way of continuity correction is number line. So use number line for continuity correction. And this is the way to change the distributions. So normal is mu sigma square, and this is the formula for normal, x minus mu over sigma. So this is the approximation, and you just need to replace x with x plus minus 0.5, mu by lambda, and sigma by under root lambda. We'll use this thing. Number line. Well, this is the best way for continuity correction. X greater equal to 50. So the first integer, possible integer, is 50. According to this inequality, you always mention the first possible integer on the number line. And whenever you go on this side, you always take lower bound of the number. Always take lower bound whenever you go on right side on number line. So the lower bound of 50 is 49.5. So according to this formula, you will have z greater equal to 49.5 minus lambda over under root lambda. Lower bound. The first possible integer will be 51, because this is exclusive. So 51, write 51 here and take the lower bound because you are going on right side. So this will be the formula for z. Write the first inclusive integer and then take the lower bound of 51 in this case. Whenever we go on this side, we take lower bound. Whenever we go on this side, we always take the upper bound. Take the lower bound for these inequalities. When we have less than equal to 60, the first possible integer must be 60. So since we are going on left side on the number line, so we have to take the upper bound, 60.5. This integer is exclusive, so 59 will be the first possible integer. The largest possible integer according to this inequality is 59. Since we are going on this side, so we have to take the upper bound. This will be the formula for z. Take the upper bound for these signs. The best way to learn this, whenever you go on this side, take the upper bound. Whenever you go on this side, take the lower bound. That's it. This is so simple. Now this is very important. This number is exclusive, so 41 will be first possible integer and 70 will be the last possible integer according to this inequality. For 70 we are going on this side, so we have to take the upper bound. In this case, the first possible is 41 and we are going on this side, so we have to take the lower bound of 41. See, we are going here with respect to 41, and for 70 we are going here. So we have to take upper bound here and lower bound here. This will be the formula for z. We already have discussed this. Care must be taken to specify the interval being considered. I mean, make sure you write the true value and correct value of lambda. Example, June 3, question 6. There are one computer breakdown in 48 hours. So computer breakdown in 8760 hours will be x. When you will do cross multiplication, you will get this thing. You can even write lambda here. So lambda will be 182.5. Since lambda is greater than 15, so we have to use normal approximation. And this is the normal approximation. We replace mu by lambda and sigma square by lambda. We need this probability. So the first possible integer must be 201. Since we are going on right side on the number line, so we have to take the lower bound of this number, which will be 200.5. And this will be the formula of z. 200.5 minus lambda over under root lambda. When you will simplify this, you will get this thing. And you all know how to do this on normal distribution. You need this area. If you are using the latest calculator, latest version of the calculator, then you should first get this area. This area will be 0.408. You should watch my lecture of normal distribution if you want to be good at this part of the normal distribution using the latest calculator. Normal distribution with latest calculator. You should watch my lecture 2 on normal distribution, of normal distribution on YouTube. Well, get this area, this is 0.408. Since we need this area, so we all know the total area is 0.5. So when we will subtract this from 0.5, we'll get this area. So to get this area, subtract this from 0.5. That's the answer. You can write this in terms of phi as well. This will be 1 minus phi 1.332. Well, an important advice for me and for everyone, we should be honest. And I hope this lecture will help you to understand the concepts of this chapter well. Inshallah, I will make the next lecture on important questions of Poisson distribution soon. Allah Hafiz.